Hi there. Today I'm going to show you how to subtract mixed numbers. Now I'm going to do this by using two different methods. We're going to end up with getting the same answer, of course, but I'm going to show you that way you guys can get the option of whichever way works best for you. So let's take a look here. I got 8 1/2 minus 5 3/4. Now the first thing I want to do is I want to analyze these two fractions. So we got 1/2 and 3/4, and I have a 2 in the denominator here and a 4 in the denominator here. We need these denominators to be identical. So in order to do that, I look at the larger number first off and say, does this smaller number divide into the larger number? Yes, it does. So because it divides into the larger number, that implies that the larger number must be my least common denominator. So I'm going to write it down up here. LCD is going to equal 4. So in order to get these to 4, this one's already at 4, 3/4, we are good. We're done with that. But this one needs a 4. So in order to get this to 4, you have to think, well, what do I have to multiply in order to get this 2 to 4? Another 2, of course. 2 times 2 is 4. However, you want to also multiply it by over a 2 because this is 1. So technically you're just multiplying this fraction by 1, and it's not really changing anything to the fraction. It's just increasing this fraction by a multiple of 1. So we're going to rewrite this now. This implies that 8 and 2/4 minus a 5 and 3/4. Okay, so once we have that determined, now the next part of this problem is we're going to want to look at these fractions again. And if we notice 2/4 minus 3/4, that's going to be a negative 1/4. However, we want a positive number when we subtract this and this. It's going to have to equal a positive number. And in order to do that, we do something called a borrowing. So we basically going to have to borrow 1 from here. So we just are literally reducing this number by 1. So we got a 7, and now in order to do that though, we have to compensate by a 1. So we have to add 1 to this fraction. As I described over here, 4/4 is also 1, so we're just adding 1. Okay, so let's rewrite this. This implies that we got a 7, and 4 plus 2 is a 6/4. 6/4 minus a 5 and 3/4. And now this one is basically going to equal 7 minus 5, which is 2. And then 6/4 minus 3/4, well, 6 minus 3 is 3. So that becomes 3/4, 2 and 3/4. Now let's look at this other method I was describing here. I'm going to just kind of draw right here. So we got 8 1/2, and we are subtracting off 5 3/4. And the first thing we're going to try now is let's convert these into irrational fractions. Let's try that. So what we do is we do 8 times 2, which is 16, plus 1. So that's a 17. 17/2. And we're going to subtract that off from, well, 5 times 4 plus a 3. That's 5 times 4 is 20 plus a 3 is 23. So 23 over 4. See, the denominators stay the same right here. So now what we do is we have to find the LCD. And we already previously found the LCD, which is 4. So we're going to go ahead and see what makes this turn into a 4. And we're going to basically multiply by a 2 over 2. And this is going to become 34, because 2 times 17 is 34, over a 4 minus a 23 over a 4. Well, 34 minus 23, that equals 11 over 4. Okay, so we got 11 over 4. However, it doesn't quite look like a mixed number yet. So let's change 11 over 4 into a mixed number and see if we have the identical answer. So in order to do that, we take 11 divided by 4. And you notice 4 only goes into 11 2 times. Because if this is a 12, 4 would go in 3 times, but it only goes in 2 times. So we're left with a 2. Our denominator just comes right down here. It doesn't change. And so we go 2 times 4 is 8. And 8 plus what equals 11? Well, that would be 3. 8 plus 3. So you can check your answer. You got 8, 9, 10, 11. Bang. So that's how you subtract mixed numbers. I hope you found this lesson to be very helpful.